Now potential at an axial point. Now we have already derived formula for electric potential due to a dipole, and we get formula V is equal to 1 upon 4 pi epsilon 0 P cos theta upon R square. Now let us consider case number 1, potential at an axial point. Now we have a electric dipole containing two opposite charges plus q and minus q. Separation distance between these two opposite charges is twice a as shown in the figure. Now let us consider a point P, and point P is present on the axis of the electric dipole. Let x be the distance of the point P from the center of the dipole. Now, as point P is present on the axis, along the axis of the dipole, so angle made by the line OP with the axis of the dipole is 0. So theta is 0, and as our point P is present on the RHS side of the charge plus Q, so we will consider theta equal to 0. If charge is present on the LHS side of the charge minus Q, then we consider theta is equal to 180 degree. Now as point is present on the RHS side of the charge plus Q, so let us take theta equal to 0 degree. Put cos 0 equal to 1. So we get V axial equal to 1 upon 4 pi epsilon 0 P divided by R square, because cos 0 value is 1. Now let us consider case number 2, and we are finding potential at an equatorial point. Now if you observe the diagram, then point P is there and point P is present on a line which bisect the dipole in two equal parts. Now distance of the point P from the center of the dipole is small r, and that line makes an angle 90 degree with the axial line. So theta is 90 degree. Cos 90 is 0. So if you put cos 90 value in the formula, V is equal to 1 upon 4 pi epsilon 0 P cos theta upon R square, then RHS term becomes 0. So we have a potential V equal to 0 when point is present on the equatorial line. Now let us solve example 8.7. A short electric dipole has a dipole moment of 10 raised to minus 9 coulomb meter. Determine electric potential due to a dipole at point distance 0.3 meter from the center of the dipole situated on the axial line, second on the equatorial line, and on a line making an angle 60 degree with the dipole axis. Now if you read the problem, then they have given electric dipole moment, and it is denoted by symbol small p, which is equal to 10 raised to minus 9 coulomb meter. Then point is there and its distance is 0.3 meter from the center of the dipole. So R value is the one. R value is 0.3 meter. Now let us first write formula for electric potential due to a dipole, which is V is equal to 1 upon 4 pi epsilon 0 P cos theta upon R square. This is our in general formula for potential due to a electric dipole. Now let us calculate value of the potential at that point on the axial line. So whenever we consider axial line, one has to consider value of theta equal to 0 degree, cos 0 1. So we have formula V is equal to 1 upon 4 pi epsilon 0 P divided by R square. Now put the value of 1 upon 4 pi epsilon 0 as 9 into 10 raised to 9 into value of P is 10 raised to minus 9 and value of R is 0.3 square. If you calculate that value you will get answer 100 volt. Now let us calculate potential on the equatorial line. Now whenever point is present on the equatorial line, then that line always makes an angle of 90 degree with the axial line. So theta is 90 degree, cos 90 is always 0. So if you put value of cos 90 in the RHS side of the potential formula, you will get V is equal to 0. Now let us calculate potential on the line making an angle 60 degree with the dipole axis. Now in this case, they have clearly mentioned theta is 60 degree. So cos 60 is, what about cos 60? Half, right? So put the value of cos 60 half, all other values are as it is. If you solve RHS side, you will get answer V is equal to 50 volt.